So now we want to treat this idea of percentiles. Remember that the nth percentile is the value with n% of the data below it. So for example, if we ask, what does it mean to say that your weight is in the 40th percentile? That means that 40% of people weigh less than you. Okay, so 40% of the data is below your weight. Percentile actually represents an area on the bell-shaped curve if the data is bell-shaped. And in order to, sometimes what we're interested in is finding the percentile, and then sometimes what we're interested in is if we have the percentile, what is the probability that someone's in that percentile? So let me motivate this by looking at an example. So here in example 8, we want to know what is the z-score. What's the z-score that corresponds to the 90th percentile? So 90th percentile, that is an area. Okay, that is telling us that the area to the left of that percentile is 0.90. So we don't know what that z-score is exactly, but we do know that it's on the right-hand side, right? Because 50% of the area is in here, so 90% of the area, that cutoff's going to have to be up here somewhere. And so this area is 0.90. Okay, and we want to know, what is that z-value? What is that equal to? Well, that's where inverse norm comes in on your calculator. So inverse norm, you plug in an area or probability, gives you the z-value with the area to the left of that z is a. So this number that you're plugging in here. And that's with mean 0 and standard deviation 1. If you want to change these, then you have to fill in more entries in inverse norm. But here, we want the z-value with 90% of the area is to the left. So that z-value is going to be inverse norm. And then our left area is 0.90, so 0.9. Let's key that in the calculator. So second variables, inverse norm is number 3. We're going to put in our 0.9, enter. Mean and standard deviation stay the same, so we're just going to paste. And error domain, I must have hit a key wrong here. Let's try that again. So let's quit out of there. Oh yeah, I got an inverse norm inside of an inverse norm somehow. Okay, so number 3, inverse norm. Okay, that did that again. Okay, so I want 0.9 here. Paste. There we go. Inverse norm 0.901. 1.28. And usually do z-values to 2 decimal places. So this z-score is 1.28. The area to the left of z equals 1.28 is 0.90, or 90% of the data is to the left. Or also, if you pick a random individual, the probability that their z-score is less than 1.28 is 90%. So area equals probability equals proportion of the data. So why don't you go ahead and try Canvas homework 2.6, I'm sorry, 6.2, problems 5 and 6.